Hi guys, this is video 2 for Tuesday, March 31st. So we're going to do area of a trapezoid, rhombus, and kite. It's learning target 2. I can calculate those areas. Again, remember, if you need to, pause the video and write everything down if I'm going too fast. Alright, so the area of a trapezoid. Okay, so I'm going to write area of trap. When I do it on my answer keys and things, it is going to be a 1/2 base 1 plus base 2 times the height. So remember that in a trapezoid we have two bases. We usually put base 1 at the top and base 2 at the bottom. Okay. And just like in our other shapes, our height has to create a 90-degree angle. So my height is actually going to be here. It's going to be the altitude. But I also can give it outside the trapezoid, just like in a parallelogram. Now, for your project, okay, I'm going to give you guys some tips and tricks for your project to kind of help you design, because some of the shapes are going to get complicated as we go. When you create a shape in your project, you're going to have to find the area of it, which means you're going to want the dimensions we use in the area formula to be kind of easy and nice to keep it simple. So, you know, these 3 dimensions here, you want them to be nice. So for your design, you should probably first pick a realistic height. And then once you know what height you want, you're going to, this isn't for your sketch. You're going to have a sketch that you're going to have to give me, but this is for like the final project, the one you do on the poster board. So you're going to decide a realistic height, and then you're going to draw one of your bases. So whatever length you want that base to be, you're going to draw it, or need it to be. And then, let's see, there we go. And then after that, you're going to create a 90-degree angle and draw the height. And then you'll draw your second base at the end of that height. Okay, so I know you don't know much about your project. I gave you the intro and hopefully you read it over. But you're going to create a sketch. On the sketch you're going to have what it would be in real life, the lengths. Okay? And then you're going to create a poster board, and you're going to take that sketch and draw it using a scale. Okay, so I might go from feet to inches. Okay, you want to pick a really easy scale, something that will be nice, give you whole numbers, and won't make your life difficult, because you have to measure those distances out in inches perfectly. Okay. So when you do that, these are the steps for that poster board. Okay, so once you pick a scale, and then you pick a height that kind of works with the scale, so you get nice numbers. You're going to draw one of the bases, create a 90-degree angle, draw a height, then draw the second base. That's how you're going to do your trapezoid, so that your trapezoid comes out nice and easy. Okay. This will keep your heights realistic, and you'll have nicer numbers. All right, next we have a rhombus, but we're going to derive the formula. So we talked about the word derive before. Derive means we're just going to take previous knowledge that we have about something and use it to create a new piece of information. So in this case, we're going to take some knowledge that we have about some of our shapes, and we're going to create an area formula for the rhombus. Okay, so you won't ever have to do this again. Once we have the formula, you're just going to use the formula. But I want you to know where it comes from. So I have a rhombus, and I know that a rhombus sides are all equal. And I can draw in diagonals. When I do that, I create 4 triangles. And if we remember, our diagonals bisect at a 90-degree angle. So not only do I create 4 triangles, but they're 4 right triangles. I also know that the diagonals bisect each other and the diagonals are equal. So when we did our rhombuses in our quadrilateral unit, when we had diagonals, we knew that, they're not equal, but they bisect each other. So these are equal and those are equal. Okay. So that means that if the whole diagonal here is diagonal 1, this is half of diagonal 1. And if this whole diagonal here is diagonal 2, this is half of diagonal 2. So if I were to find an area of just one triangle in my rhombus, I know area of a triangle is 1/2 base times height. The base of my triangle is 1/2 diagonal 1. And the height of my triangle, so if I'm focusing on this triangle, guys, the height of my triangle is 1/2 diagonal 2. Okay, if I were to simplify that all down, I could multiply all the halves by each other and I get 1/8. Diagonal 1 times diagonal 2. But that's only the area of one triangle, and I want the area of the rhombus. So all those triangles I know are going to be congruent because I have side angle side. So that means all the areas are congruent, and I can just multiply this by 4 because I have 4 triangles inside my rhombus. When I do 1/8 times 4, I actually get 1/2, and we still have diagonal 1 times diagonal 2. So that's the area of a rhombus. I use RH to denote rhombus. So this is the formula that you're going to use. I did that because I want you to understand why we use diagonal 1 and diagonal 2 in the formula. It comes from the triangles within the rhombus. All right, for your design, to make your life easier, because you have to find the areas of your rhombus, and to find the area we use diagonal lengths, you're going to want to start there. You're going to start by picking realistic diagonal lengths. So pick a realistic real life dimension. Like if I'm doing my real life dimensions in feet, I'll pick something that's nice and easy and makes sense to the real world. And then hopefully I picked a really easy scale as well, and I'm going to use that scale to scale the feet into inches, and then it'll give me nice easy numbers when I go to draw my rhombus on my poster. So on your poster, you're going to, a poster or final project, doesn't have to be a poster, but when I draw them, you're going to draw them and you're going to make sure they intersect at the midpoint and 90-degree angle, because that's what will make it a rhombus. Okay. So once I draw the diagonals, then you can connect the ends of the diagonals. Oops. And you'll have your rhombus. So it's very important that your diagonals intersect at the midpoint and are 90-degree angles. So make sure you use your ruler. If you want to use a compass and do a perpendicular bisector like we did in Unit 1, you can. It's up to you. All right. Next, we have area of a kite. Okay. Area of a kite is very similar to area of a rhombus. You use the triangles and the diagonals, create the triangles. Okay. So the area of a kite is 1/2 diagonal 1 times diagonal 2. So it's actually the same exact formula as a rhombus, and that's because it uses the idea of finding the areas of the triangle inside the kite. For your design, you're going to do it very similarly. Because you're using the diagonals to find the areas, you're going to make sure, find a realistic length for the diagonals. You're going to draw your small diagonal first. You're going to find its midpoint, because remember, the large diagonal bisects the small one. So you have to find the midpoint, and then you're going to draw the other diagonal. So draw a long diagonal through the midpoint. And 90-degree angle. Okay, and then after that, you'll just connect the ends of the diagonal. And you'll have a kite. All right, so that's how you can create a kite on your project and make sure it's a kite. Okay, again, nice, easy numbers. Keep it simple, guys. We don't need to overcomplicate this project. Okay, you want an easy scale and an easy, realistic length. All right. So I have a problem next. Just like in the other video, I want you to draw the diagram down, pause the video, and try it on your own first. Then watch me do it and see if we get the same answer. So go ahead and pause your video. All right, so now that you've tried the problem on your own, I have this shape here. I recognize that is a trapezoid, so I need to find the area of a trapezoid. And I know that formula is 1/2 base 1 plus base 2 times the height. Okay. So I'm going to identify some of those dimensions that I need. This is my base 1, this is my base 2, and I need a height. I actually don't have a height. This would be a good place for one, but it's not given to me. It's a good place because it has 90 degrees. So I'm going to actually have to find my height for this problem before I can find the area. All right, so if I draw this in, I have now created a right triangle where the height of the triangle is the height of the trapezoid. It starts at the top of the trapezoid, ends at the bottom of the trapezoid. Okay, that triangle has a 60-degree angle, so in my brain, I should be going, oh, I have a 30, 60, 90 triangle, which means it's a special right triangle, and as long as I have one length of that triangle, I can find all of them. So now I need a part of that triangle. So I'm not going to be able to find the hypotenuse, but if you take a look, 10 is the length of all of this, okay, and 6 is the length of all of this. And if I were to bring that down, from there to there is 6, which means this part has to be 4 if the whole thing is 10. So this is the short side of my right triangle. So if I go to short to the long, I need to multiply by square root 3. So my height is actually 4 square root 3. So there's my height. All right, now I use my formula, 1/2 base 1, which is 6, plus base 2, which is 10, times my height, which is 4 square root 3. I'm going to leave this in simplified radical form, but again, since we are talking area, you can give me a decimal as long as there's not pi in the problem, that is okay. So when I multiply the half, the 16, and the 4 together, I get 32, and then I have the square root 3. And they don't give me units, so I put units squared. All right, I'm going to go to the next problem. Make sure you copy the diagram down and pause the video and try it on your own. So go ahead and pause the video. All right, now that you've tried it on your own, we're going to do it together. I recognize this shape as a rhombus, and I know the rhombus area formula is 1/2 diagonal 1 times diagonal 2. Okay, so I'm going to look on my diagram and see if I have those pieces of information. I don't have anything about the diagonals, but I have a side length, so I know all the sides are 10 inches. And they give me an angle measure here. Now, if I remember, the diagonals in a rhombus intersect at 90 degrees, so that is a right triangle with a 30-degree angle, making this 60 degrees. And now I have a special right triangle, and I have one of its sides. I have the hypotenuse. So I need the diagonals. So if I can find one piece of the diagonal, I know that these are equal, so I can multiply by 2 and get a diagonal length. And the same thing here. If I can find the length of this diagonal, it is equal to that. So if I multiply by 2, I have the whole diagonal's length. So that's what I'm going to do. I have the hypotenuse. I'm going to go to the short side, which is dividing by 2. So this is 5. This is also 5. So my diagonal 1 equals 10. And then I go from the short side to the long side. I need to multiply by square root 3. So this is 5 square root 3, and so is this. So my diagonal 2 is 5 square root 3 plus 5 square root 3. Remember, when we add, you treat the radicals like exponents. So I'm not going to change square root 3. It's going to stay just like if it was 5x plus 5x, okay, for instance. So this is going to be 10 square root 3. All right, so now over here on my area, I'm going to do 1/2 diagonal 1, which was 10, times my diagonal 2, which is 10 root 3. Again, I'm going to leave this in simplified radical form, but technically it's area, so you could give me a decimal. I'm going to multiply 1/2, 10, and 10. I'm multiplying all the outside numbers. When I do that, I get 50, and then I have the square root 3. And it did give me units. I have inches right here. So my units are inches squared. All right, the next problem. Make sure you copy down the diagram and pause the video and try it on your own. So go ahead and pause the video. All right, now that you've tried it on your own, we're going to do it together. I noticed that this shape is a kite. And I know that's going to be 1/2 diagonal 1 times diagonal 2. So those are the two things I need, is diagonal 1 and diagonal 2. They give me that this is 3, and I know that that's the short diagonal. And I know the short diagonal gets cut in half from my quadrilaterals unit. So this is also 3, making diagonal 1, 6. I need to find, oh, nope, they give me, sorry, right here, this is 12. That is the same as this diagonal right here. It's just down here. So diagonal 2 is 12. So over here, I put in my diagonal 1, which is 6. Put in my diagonal 2, which is 12. And I multiply all of that together. When I do that, I get 36. And it does have centimeters here, so it's centimeters squared. All right, and that's how I find areas of trapezoids, kites, and rhombus. So you have homework that is assigned to you on the post from today, so make sure you do